Hi, I'm David Chadwick. Sorry I can't be with you in person today to answer any of your questions, so please email me afterwards if you want to ask anything. Thank you. There's no computer science definition for self-sovereign identity, but all the ones that I've come across and read have one thing in common, and that is putting the user in control of his or her digital identity. A number of people have been building SSI and VC systems for a year or two, long before COVID-19 started, including my group at the University of Kent. But once COVID burst on the scene, then the number of people experimenting with COVID-19 certificates seems to have exploded. The reason is that verifiable credentials are an excellent basis on which to build COVID-19 certificates. In fact, on any type of certificate, because they've got a really nice set of properties which are listed here. They are really a fundamental building block of self-sovereign identity because they put the user in control of their identity attributes. However, the VC data model on its own is not sufficient to build into working SSI systems for the reasons given here. For a start, no protocols have been standardized, which is why we're currently looking at integrating verifiable credentials with OpenID Connect. But until most of the above are standardized or resolved, we won't see global acceptance of SSI or VCs. So what is the VC SSI model? This is taken from the W3C standard, and it shows there are three roles involved in the system. There's the VC issuer, which issues VCs to holders. There's the VC holder, which holds VCs in its wallet, and there's a VC verifier, which verifies VCs. And importantly, you will see that the holder is the center of the ecosystem. It's in control. It decides which VCs it will pick up and hold, and it decides which verifiers it will give them to. Typically in any system, there'll be orders of magnitude more verifiers than issuers. For example, with credit cards, there are a lot more places will accept credit cards than issue credit cards. Now at the bottom of the diagram, you'll see the verifiable data registry. This is where all the meta information is stored. It's important that all the system components have a same understanding of how the system operates. So all the system components have to have this meta information configured into them so that they can operate correctly. I'll say more about the verifiable data registry later. Note what the W3C standard says about DIDs. They are not needed. It's important to bear that in mind. They are not needed. However, when you read a lot of the SSI literature, you would wrongly believe that decentralized identifiers and a blockchain are absolutely mandatory for building an SSI infrastructure. But this is not true. DIDs and blockchain are not mandatory. They are one way of building an SSI infrastructure, but they're not the only way. And I believe actually they're not the best way. When you take into account all the non-functional requirements that are listed above, such as total cost of ownership, ease of integration into existing infrastructures, user acceptance, etc. So how do we get to believing that DIDs and blockchains were mandatory for building SSI? Here are my hypotheses for this. I might be wrong, but anyway, they're my best guesses at why many people believe they're mandatory. First of all, confusion between identifiers and identity. I've come across this a lot in my academic career, and it is quite prevalent. A desire to escape centralized allocation of IDs. Christopher Allen, who's one of the chief architects of SSI, has said this is one of his objectives. Misunderstanding. I think this is also true, and I'll show you where I think that's the case. Disillusionment with PKI. I'm sure we've all been disillusioned with PKI at some point in time in our careers. Blockchain bandwagon. Well, I'll leave you to be the judge of that one. Before trying to disentangle identifiers from identity, let's briefly look at what is identity. Now, this is a massively complex subject, so this is necessarily a simplification. But identity is a whole lot of personal information that describes you or characterizes you, and vast majority of it is actually created by other issuers, other people, organizations about you. And then you decide which bits of your identity you want to release to other people or other entities. So my mum would know a bit about me, and the bank could know a bit about me, and when I buy something online, that'd know a bit more about me. But these recipients of my identity, none of them know all about me because I keep that under my control. So to summarize, identity is a set of identity attributes, mostly signed by others, but you can self-assert some yourself if the receiver trusts you to do that. And if you want to read more about this, then I've written more about it in the Verifiable Credentials Lifecycle document, which you can download from the W3C website. The URL's there. Many people confuse identifier with identity because in original computer systems they were the same. Your login ID was your identifier and it was your identity. But in more sophisticated systems that we have today, they're not equal. An identifier is a special identity attribute that uniquely identifies the user from all other users. And all issuers create identifiers. They have to, because these are the primary keys in their database which allow them to differentiate one user from the other. But just because an issuer has an identifier for you in its database doesn't mean that it has to be released to you in SSI. So whilst every identity issuer creates identifiers for its own convenience, it doesn't necessarily have to make them available to you. Some systems actually allow you to participate in the creation of the identifiers for you. For example, in DNS names and email addresses, you actually create the last component yourself. Finally, users can create their own globally unique identifiers in a distributed manner. For example, when users create their asymmetric key pairs for PKI, then they're all independently creating their own unique identifiers. When some identity providers issue physical identity tokens such as certificates or ID cards, they may put their centralized identifier on the token, but this is really for their own convenience so that they can actually check in the database that this is a correct and not a fraudulent token. But it really serves no other purpose, not for the user and not for verifiers that are not linked to the issuer. In the physical world, the user must reveal the identifier and all the identity attributes to the verifier. There's no choice. They're all there and he has to present them all. But in the virtual world, we've got selective disclosure, so the identifier doesn't need to be revealed. It will only be revealed if the verifier needs it. And under GDPR, this means it must be essential for the transaction. If it's not needed, it won't be revealed. So it will stay back in the issuer's database and not be visible. As this example shows here, it's not there. The only thing the verifier needs to know in the virtual world is, were these attributes issued by the trusted issuer, and do they belong to the person who is presenting them to me? By its own admission, the DID's ideology is to actually get rid of centralized identifiers and to replace them with distributed identifiers. That's their objective. And Christopher says this is because of the identifier problem. These centralized identifiers don't belong to us. They can be taken from us, and he sees them as our identifiers. But I think this misses the point. They're not actually our identifiers. They are the issuer's identifiers, and he needs them in order to differentiate one user from the other. They're the unique keys into their database. So they're not going to get rid of them. They absolutely have to have them for their system to operate. Furthermore, if you don't actually have a driving license, you don't need a driving license number. If you haven't got a passport, you don't need a passport number. If you don't have a telephone, you don't need a telephone number, etc. So these centralized numbers are only needed anyway if we actually have the service that the issuer is providing. And then more importantly, in the virtual world with selective disclosure, there's no need for these identifiers to even leave the issuer's database unless the recipient needs it. For example, it's an email address and it needs it to send email to us. So there isn't actually an identifier problem. However, there is a problem with DIDs, because DIDs are persistent, globally unique handles stored on a blockchain that will always uniquely identify you and you alone. So it actually reduces your privacy protection. So this is a problem. As previously shown, there's no need for any additional identifiers to be sent along with your identity attributes. The identity attributes on their own are sufficient to identify you. And if they need to contain unique identifiers because the recipient requires them, then they can be included along with your identity attributes. In Christopher Allen's famous seminal work, The Path to Self-Sovereign Identity, he specifically omits the word identifier, for simplicity, he says, and merges the two terms, identifier and identity, into identity. Now this actually leads to confusion, as I'll show you in the next slide. And I've written to Chris and said, look, I think it'd be a good idea to update your principles to separate out identifiers from identity. Here's a simple example of why conflating two similar but different terms together and making statements that are true about one or the other and combining them. Clearly, we shouldn't do this if we want to avoid ambiguity or misunderstanding. And this is why I'm suggesting that the principles of self-sovereign identity ought to be clarified and updated. I think we've probably all been disillusioned with X509 and CAs and the PKI infrastructure at some point in our careers. That wouldn't be unusual. But new techniques like OCSP stapling and Google certificate transparency are helping a lot to make them more trustworthy. If we go back 20 years, you will see that PKI was the saviour of the world, just like blockchain today is the saviour of the world. We really will need to go 20 years into the future to see how blockchain reality compares to blockchain promise. But unfortunately we can't do that. However, what we can say is that blockchain has already failed its promise of being unhackable, as there have been many hacks in the last couple of years. Blockchains may actually be useful for SSI for storing the meta information, and here's a list of all the meta information that could potentially be stored in a blockchain. So let's look at each of these pieces of meta information one by one. At context definitions, well, these are already published on web pages, so there's no need for a blockchain for those. The public keys of issuers and the identity attributes that they issue, well, these are actually the trust store for the verifiers. So they must be configured out of band, because no verifier is going to trust every conceivable VC issuer on the blockchain to issue every attribute that's specified there. So these have to be configured out of band into the verifiers. VC schemas, these should be configured into end systems as well, because you can't have a system accepting attributes and terms of use that it's got no knowledge about. Finally, certificate transparency. Some people have said we should every issuer should publish the ID of the VC that it's published on the blockchain, so everybody knows that it's there. But Google already does this for public key certificates. It doesn't need a blockchain, so there's no requirement for that to be on a blockchain. And finally, revocation information. Yeah, that's also been proposed for a blockchain, but there's a new work item in the CC working group to produce open source code for a compressed revocation list, 1 bit per verifiable credential, that again won't be published on a blockchain. So whilst a blockchain could be used for meta information, there's no requirement to use it, and in fact all the pieces of meta information that are needed can actually be handled without using a blockchain. So now we come to the real meat of the presentation. How do we build a self-sovereign identity infrastructure without using DIDs and blockchains? There are two components that are needed in this. There's the VC issuing subcomponent and there's the VC verifying subcomponent, and the user or holder is part of both components and is the link between the two. The first thing the user must do is register with each of his VC issuers, and during that registration phase is going to establish a FIDO2 authentication link with each issuer, and that's going to generate key pairs, one key pair for each issuer, and they're going to be stored in the device's hardware or in a portable FIDO2 key store. So this prevents the user's keys from being stolen or hacked. Now that the user has actually got an established link with his issuers, the user can authenticate to the issuer any point in time in the future by simply signing a challenge with the private key that he's got. And so the user is able to get verifiable credentials freshly minted on demand with just the attributes that the verifier wants, so thereby providing selective disclosure. And the issuer stores the FIDO's public key along with the other identity attributes indexed by its centralized identifier, and of course that centralized identifier will never need to be released unless the verifier specifically needs it. So suppose now the user wants to access some protected resource of a verifier stroke relying party. Well, the user contacts the verifier sends its policy to the user telling it which VCs it wants containing which attributes from which trusted issuers, and the user agent now creates a transient key pair for this transaction so it can prove possession of the verifiable credentials. He contacts each of his issuers with strong authentication via FIDO2, and the issuer mints fresh, short-lived, selectively disclosed VCs and attaches it to the transient public key, returns it to the user. The user then collects all the VCs together, signs them into a verifiable presentation with the private key, and sends it to the RP. When the verifier receives the VP, it checks the signature on the VP, and that shows that the user possesses the private key and the corresponding public key. The public key is embedded in the VCs, which have been signed by the trusted issuers, so the verifier can see that all the VCs belong to the user, and no DIDs are needed and no blockchain is needed. This is a diagram of the verifiable credentials application independent middleware that we've built based on the W3C FIDO2 web authentication standard and W3C verifiable credentials data model standard, and it shows the three APIs that we've defined for interfacing with the application layer. The proof of pudding is obviously in the eating. Does this work? The answer is yes, it does work. You can see a video of it. We were actually the first people in the world to create a COVID-19 certificate demonstrator, because we built it on our existing verifiable credential infrastructure in just a few days, and we published it at the beginning of April this year. So thank you for listening. If you want to ask me any questions, I left my email address on the first slide, so please feel free to email me anytime. Thank you.